Today's lesson is on multiplication exponent properties. We're going to start off with a little investigation dealing with properties of exponents. So you'll see the problems over here on the left hand side. We're going to expand each of these problems and then we're going to give a simplified exponential form for them. So if I look at the first problem, 2 to the second power can be rewritten as 2 times 2. And 2 to the third power can be rewritten as 2 times 2 times 2. So 2 to the second power multiplied with 2 to the third power is 2 times 2 multiplied with 2 times 2 times 2 times 2. So we can rewrite this in exponential form by just counting the number of 2's that we have. So 1, 2, 3, 4, 5. And we're going to keep the base the same. So our base is going to be 2. And we have it written to the fifth power. So this is 2 to the fifth power. Now this number can be simplified. So if we multiply this all the way out, 2 times 2 times 2 times 2 times 2, we get an answer of 32. In the next problem, we have 3 to the fourth power. So that would be 3 multiplied by itself 4 times, which looks like this. 3 times 3 times 3 times 3, multiplied with 3 multiplied by itself 2 times, which is 3 times 3. So we're multiplying these two sets together. So again, we're going to keep the base the same. So 3 will be our base, and then we have a total of 1, 2, 3, 4, 5, 6. So we rewrite that as 3 to the sixth power. Now if we multiply this all the way out, 3 times 3 times 3 times 3 times 3 times 3, we would get a total of 729. Now this is written a little bit differently because it has variables here, and we're using parentheses instead of the multiplication symbol. However, the rules still apply. So here I have x to the second power, which expanded would be just x times x, and I'm multiplying that with x to the third power, so x times x times x. So x would be our base, and we have a total of 1, 2, 3, 4, 5 x's, so this is x to the fifth power. Now this doesn't equal any number because we have a variable, so it's just x to the fifth. Lastly, in this last example, we have p to the fourth, so that would be p multiplied by itself 4 times, which looks like that, and then p multiplied with itself 5 times, and then finally multiplied by just a single p. So we're multiplying that whole thing together, so we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 p's, so the base stays the same as p, raised to the 10th power. So we can come up with some general rules for this, and if you haven't noticed what's going on here, what you're really doing is you're taking the base and keeping it the same. So if I have an a raised to some power, and I am multiplying that with the same base, a raised to another power, all you're going to do is add the two exponents together. So this is the general rule. Whenever you're multiplying with the same base, we add the exponents. So in this next example, what we're going to do here is we're going to first apply the property that we just learned, and then give a simplified answer in a number if we can. Otherwise, we're going to leave the variables in the problem. So looking at this, I have 3 to the fourth power, and I'm multiplying that with 3 to the fifth power. Now in this first example, I'm going to write it all the way out, just like you saw in expanded form. So this would be 3 times 3 times 3 times 3, multiplied with 3 times 3 times 3 times 3 times 3. So I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 threes. So this is 3 to the 9th power, which we got that from 3 to the 4th plus 3 to the 5th. So I added the two exponents together. Okay, so my final answer is 3 to the 9th or 19,683. In B, I have b to the 5th, multiply with b to the 6th, multiply with b. Now, just because you don't see an exponent here, there's an implied 1 for the exponent, so don't forget to add that at the end. Okay, so I'm not going to do the expanded form here. I'm just going to go right to exponential form. So I'm going to apply my rule. So I have b to the 5th. My base is the same, so I'm going to add to the 6th power. My base is the same, so I'm going to add in that 1. So I have a total of 5 plus 6 is 11, plus 1 is 12, so my answer here is b to the 12th power. In C, same thing. I'm going to write it in exponential form. So this would be a to the negative 3rd, added with, a has the same base here, so I'm going to add 6. B, however, is not the same base, so I'm just going to multiply that by b at the end. So now I want to simplify this expression here. So negative 3 plus 6 is going to give me a positive 3. So this is a to the 3rd. And now I'm multiplying it by b. So my final answer is a to the 3rd times b. Lastly, in D, even though I have parentheses, the same rule applies. I am multiplying with the same base. So I'm going to add the two exponents. So this is c raised to the 3rd plus 8. 3 plus 8 is 11. So my final answer is c to the 11th power. What I'd like you to do now is pause the video and try the next 3 U-tries on your own. When you've completed the problems, go ahead and unpause the video and check the answer. If you worked out the 3 U-tries, for A, you should have gotten 4 to the 12th power, which is 16,777,216. For B, you should have gotten B to the 8th power. And for C, you should have gotten 2 to the 10th power multiplied with A to the 6th, which simplifies to 1,024 A to the 6th power. In this next investigation, we are going to be raising a power to a power, also known as exponents raised to an exponent. Okay, so these are a little bit different because now I'm taking 2 to the 3rd power and I'm raising this whole expression to the 2nd power. So what this looks like in expanded form, 2 to the 3rd power becomes 2 times 2 times 2, but I want to do that twice. So I have 2 times 2 times 2. For the first time, and then for the second time, 2 times 2 times 2. So I'm multiplying them together. So if you count the total number of 2's that we have, 1, 2, 3, 4, 5, 6, we can rewrite this as 2 to the 6th power. Again, since this is a number raised to an exponent, it can simplify, and that simplifies to 64. Notice in this next problem, I've flipped the 3rd power and the 2nd power from the 1st. So now this is 2 to the 2nd multiplied, raised to the 3rd power. So 2 to the 2nd power wants me to do it 3 times. So here's 2 to the 2nd multiplied with 2 to the 2nd multiplied with 2 to the 2nd. Remember, 2 to the 2nd is 2 times 2, 2 times 2, 2 times 2. So I still have a total of 1, 2, 3, 4, 5, 6. So this is 2 to the 6th power, which we just said simplifies to 64. Okay. So these two problems are very, very similar. What similarities did you notice? Well, 2 to the 3rd, we wrote it 3 times, but we only had 2 sets. 2 to the 2nd, we wrote 2 times, but we had 3 sets. So the end result is the same as 2 to the 6th, or 64. So we'll keep going on. Think about what similarities they might have had and how you arrive to 2 to the 6th power. So in this one I have 2 to the 2nd power, so just like what we did here, raised to the 4th power. So now I'm going to do it 4 times. So 2 to the 2nd times 2 to the 2nd times 2 to the 2nd times 2 to the 2nd. So now I have 2 times 2 times 2 times 2, so that's a total of 4, times 2 times 2, a total of 6, times 2 times 2, a total of 8. So this is 2 to the 8th power, which is 256. Have you picked up on what the property is yet? If not, we'll do 3 more, this time with variables. So here I have a to the 5th. We're going to write out a 5 times. So a times a times a times a times a. And we're going to do that 2 times because we're raising it to another power. So the second time would be a times a times a times a times a. And if we multiply these together, we have a total of 10 a's. Again, since we have a variable, it doesn't simplify to any number. It just stays a to the 10th. Here I have w to the 5th power raised to the 3rd power. So I have w times w times w times w times w. So that's one time, multiplied with w times w times w times w times w. A second time, and now I need one more time for a total of 3. So times w times w times w times w times w. So count the total number of w's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is w to the 15th power. Again, we just switched the variables here, so you should expect the same outcome of what happened up here. Since the first one was 2 to the 6th, and we had 3 to the 2nd power, here we had 2 to the 3rd power. We got the same result, so this answer should also be w to the 15th. So w to the 3rd power, and we're going to do it a total of 5 times. Times w to the 3rd power, times w to the 3rd power, times w to the 3rd power, times w to the 3rd power. So I have 1, 2, 3, 4, 5 sets. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 for w to the 15th power. So now, the general rule for this is that if we take a number or variable raised to a power, and that's raised to a power, what we're going to do is we're going to multiply those two powers together. So the first property we dealt with, we added the 2 exponents. This one, when you have 2 exponents next to each other, you multiply them together. So taking a look at example 2, first problem A, I'm not going to write this in expanded form. Well, I am, but not complete expanded form. I'm just going to rewrite as 3 to the 4th, and I'm going to do that 5 times. Times 3 to the 4th, times 3 to the 4th, times 3 to the 4th, times 3 to the 4th. Now in the previous example you learned that if you have a problem like this, all you're going to do is add the exponents together. So this is 3 to the 4 plus 4 plus 4 plus 4 plus 4. So we have a total of 4, 8, 12, 16, 20. So this is 3 to the 20th, which when we do the multiplication, we get 3 to the 4 times 5, which indeed is 3 to the 20th, and 3 to the 20th power is 3,486,784,401. So either of these answers would be acceptable. Looking at B, I'm not going to do the expanded form this time. I'm just going to go ahead and do the multiplication. So this is b to the 5th power multiplied with 2, or b to the 10th power. In the next problem, we have a to the negative 3rd multiplied with the negative 6th. A negative times a negative is a positive. 3 times 6 is 18. So my final answer is a to the 18th power. What I'd like you to do is go ahead and pause the video and try the next 3 on your own. When you're done, go ahead and resume it, and you should see the answers. For A, you should have gotten 4 to the 21st power, which is 4,398,046,511,104. For B, you should have gotten e to the 15th power. And for C, you should have gotten 3. So it's asking, r to the 5th power raised to what power is equal to 15? So 5 times 3 gets you to 15. Alright, so our last investigation. Here we are doing product of powers. So notice the difference between the last investigation and this investigation is now I have more than just a single variable here, or a single number. I have 2 times x times y. Whereas in the last investigation, here I had 2 to the 3rd power raised to 2, or a to the 5th power. So a single variable raised to a power, as opposed to in this investigation, I have this times this times this all raised to a power. So again, the same exponent rules apply. This 2 wants me to multiply everything inside of the parentheses by itself 2 times. So you'll see over here, expanded form, I have 2 times x times y written once, multiplied with 2 times x times y written twice. So all I'm going to do here is I'm going to multiply everything out. Remember, you add the exponents. The base stays the same. So this is 2 times 2, which gives you to 4. 2 x's, so that's x squared. 2 y's, so that's y squared. So your final answer here should be 4x squared, y squared. And again, if we're expanding in this next example, here I have 3a squared, which is really a times a, multiplied with b. And it wants me to do this 3 times. So if I expand it, I have 3 times a times b, which that's where the a squared comes from, multiplied with 3 times a times b, multiplied with 3 times a times b. So here it is written 3 different times. So we want to multiply all the 3's together. 3 times 3 is 9, times another 3 is 27. I have 1, 2, 3, 4, 5, 6 a's, so that would be a to the 6th power. 1, 2, 3 b's, so that's b to the 3rd power. So my final answer written is 27 a to the 6th, b to the 3rd. In this last problem, I have a to the 2nd, which is a times a, b to the 3rd, which is b times b times b, times c. And it wants me to do this twice. So expanded form, I have a times b times b times b times c. So again, a squared, b to the 3rd. And I'm multiplying that by itself 2 times. So a times a squared, b times b is b to the 3rd, times c. So now if we compile all the a's together, all the b's together, and the c's together, I have 1, 2, 3, 4, so this is a to the 4th. 1, 2, 3, 4, 5, 6, so that's b to the 6th. C times c, which is just c to the 2nd. So my final answer is a to the 4th, b to the 6th, c to the 2nd. So power of a product exponent property. This states that if you have 2 things or multiple things multiplied on the inside, all raised to a power, it's going to kind of act like the distributive property. So this m is going to get distributed to the a exponent, and it's going to get distributed to the b exponent. So it's going to be rewritten as a to the m power multiplied with b to the m power. Alright, so example number 3, it says simplify the following. So again, the first one I'm going to do in expanded form, and then B and C I am not going to do in expanded form, I'm just going to use the actual exponent rule. So A, it wants me to multiply 3x to the 4th by itself 2 times, so that's 3x to the 4th multiplied with 3x to the 4th. So 3 times 3 is 9. X to the 4th times x to the 4th. We'll add the exponents here. So this is 9x to the 8th power. Now one thing that I want to note here is where the 3 came from. This is really 3 to the 2nd times x to the 4th to the 2nd. So 3 to the 2nd becomes 9. 4 times 2 is 8. So my final answer is 9x to the 8th power. Looking at B, here I have 4a to the 5th times b to the 3rd, and that's all raised to the 4th power. So I'm going to go ahead and distribute to the exponents, so that becomes 4 to the 4th power. Remember, this has a 1, so 1 times 4 is 4. Then I have a to the 5 times 4, and b to the 3 times 4. So now I'm just going to simplify here. Remember, 4 to the 4th is 4 times 4 times 4 times 4, which is 256. 5 times 4 is 20, so that's a to the 20th. 3 times 4 is 12, so that's b to the 12th. So my final answer is 256 a to the 20th, b to the 12th. Lastly, in C, again, distribute this exponent to the other exponents. So this is a to the negative 3rd times negative 6, b to the negative 2nd times negative 6. That's a multiplication symbol there. Same as here. So a negative times a negative is a positive, so this is a to the 18th power, 3 times 6. Multiply with b to the negative 2 times negative 6 is positive 12. So my final answer is a to the 18th, b to the 12th. Now what I'd like you to do is go ahead and pause the video and try the next 3 problems on your own. Once you've completed those 3 problems, unpause the video and check your solutions. For A, you should have gotten 4x to the 8th, y to the 4th. For B, you should have gotten 27a to the 9th, b to the 6th. And for C, in the first box, you should have gotten 2, because 3 to the 2nd power is 9. R to the 5th power times 2, 5 times 2 is 10, so the second box should have gotten 10. 6 times 2 is 12.